Hello, hello. This is my video walkthrough for 2A, which is coordinate or ordered pairs on the coordinate plane. So this is how to do my graphic organizer, which actually is foldable for my notebooks. To start out, to prepare this graphic organizer, you're going to want to cut off what I call the paper snot. So right here all the way around, you're going to cut off that border. You should also see two dotted lines, one here and one on this side. If you cut along those dotted lines, that's going to give you 4 doors. So your graphic organizer should look something like this. These edges of the doors that you fold in, they align perfectly to this piece right here. Alrighty, so let's talk about the filling out part. So we have 4 quadrants. Okay, we cut our graph into 4 pieces. The quadrants really throw kids off because quadrant 1 is actually up here in the top right corner. The reason for that is because that's where the x and y values are both positive. So it makes more sense to put it here where everything's positive as opposed to over here where you might have negative values, which we'll talk about here in just a second. But then the quadrants follow in the counterclockwise way. Now, when we talk about the quadrants, we also only talk about them using Roman numerals. We do that because as mathematicians, we like to make things as complicated as possible. Now, I wanted to know where the quadrants were when my doors were open. So I actually made these spots in these corners just so that we could label the 4 quadrants and not be too confused about it. So these guys get our nice little labels. So to start out with, I wanted to start just kind of talking about the key pieces of it and what it looks like, and then we'll talk about how to graph on it. Oh, spoiler alert. Okay, so this horizontal axis right here, this is called the x-axis. So in this box with the arrow that points at it, I wrote the word x-axis. I also draw those cute little arrows because it makes me feel better about myself. The other axis, the vertical axis, okay, that one's called the y-axis. Sorry for having to move my iPad around. I can't write sideways. So this is the y-axis. And it goes uppy downy ways, right? That's the vertical axis. Now, when one axis loves another axis, they meet right here in the middle. Okay, we call that the origin. Now, I want to give you a heads up. The origin isn't always the exact middle of the graph, depending on what needs we have. Sometimes, depending on the types of problems that you're doing, you won't have any negative values. So these parts of the graphs might not be necessary. So often you'll see graph paper that looks something like that, where it's just the positive quadrant. So when we talk about origin, we're not talking about the center of the graph. We're talking about the center of existence, I guess, would be a good way to say it. Now, when we are graphing, we do always start at the origin, which is the ordered pair 0, 0. That's saying that we're not going left or right at all, and we're not going up or down at all. Let's talk about ordered pairs. I find that students most struggle with remembering the order for ordered pairs. So the x-coordinate, which remember is the horizontal component, goes first, and then the y-coordinate, which is the up and down ways, the vertical coordinate, goes second. Remember, they are in alphabetical order, so x goes before y in the alphabet. Now, these are number lines, okay? So on a number line, the negative numbers are to the left, and the positive numbers are to the right. So I'm writing these in these circles just to help remind us. On the vertical axis, going up is positive, and going down is negative. So to help us to kind of imagine our ordered pairs, I want you guys to think about the original Mario. I know, not Mario Kart, but like straight up the Mario that always runs to the right, pretty much. And in Mario, he used to have these little plants that were in the ground. I can't really draw them. Spiky teeth, okay? And these plants would jump up and try to bite him. So you'd have to have Mario jump over the pits. Well, the thing was if you were just hitting the jump button, the A button, you would just jump up and down like this. So in order to cross the pits, you used to have to get a running leap, then jump, and you would make it over the hip, like hump there. Okay? So in Mario, you have to run before you can jump. And that's actually how I remember our ordered pairs. You have to run, which is the x-axis, before you can jump. If you're not a big old nerd like I am, you're going to move horizontally first and vertically second. All right, so let's get into it on the graph paper. So I had to use like a real thick, bold pen for this part because I made these lines a little too dark when I made my graphic organizer. My bad, friends. So when we are designing this, quadrant 1 is to the right, which means that the x value is positive. And the y value is also positive because it's up. So any ordered pairs that are made with 2 positive numbers will always be in quadrant 1. Now, if I go into quadrant 2, I'm going to the left this time. So that means that any ordered pairs that have a negative x-axis, or negative x value, might be in quadrant 2. However, the y value is still going up. This is still above the axis here. So the requirement for your ordered pairs is that the x value has to be negative and the y value has to be positive. For quadrant 3, it comes to the left and then it comes down. So both left and down are negative. So if ever you have an ordered pair with 2 negative numbers, you know that it's automatically in quadrant 3 somewhere. And lastly, quadrant 4, we go to the right, which is positive, and we go down, which is negative. So our x values here are always positive, and our y values are always negative. So in our 4th door, I have some ordered pairs. Oh, Gibbs would like to say hello in our video. My apologies. So in our 4th door, I have some ordered pairs. We're going to be graphing those. But before we graph them, I'd like us to anticipate like where they would lie on the graph. Because sometimes we don't actually care enough to graph it. We just care like where it would be theoretically. So thinking about this, thinking about point A, it's at 1, 2. So 1 would go to the right because it's positive, and 2 would come up because it's positive. So point A would actually lie in quadrant 1 because those are both positive numbers. So the way that I would graph that is I would start with my pencil hovering over 1. We don't draw a bunch of lines to get our ordered pairs, okay? We just kind of hover. I'm going to hover 1 box to the right and 2 boxes up, which would put me right here. Now, anytime that you graph a point on a coordinate plane, you always want to label it. My points all have letters because I wanted to cut down how much like writing and junk was on your graphs. So I'm labeling mine with letters, but often we label them with the ordered pairs themselves. So make sure anytime you graph a point that you label it. All right, so looking at point B here, this negative 8 means that it would go to the left 8. This negative 5 means it would go down. So left and down gives me quadrant 3. So looking at the graph, I start at the origin, I come left 8, and I come down 5. That puts me right here for point B. Looking at point C, it's saying don't go left or right and don't go up or down. Well, that location is the origin. So I'm looking here where my two axes meet and labeling it as a C. So it's not actually in the quadrant, but it is where the 4 quadrants meet. Looking at point D, the 0 says it does not go left or right at all, but the -5 says that it goes down. So that actually places us on the y-axis. It's not in any, it's not in any quadrant, it's just on the axis, which is the boundary line between the quadrants for point D. All right, point E has a +8, so that would be to the right 8, and a -6, which would be down. So the quadrant that's to the right and down is quadrant 4. And again, that was 8, -6. So I put my pen on the origin, I come to the right 8, I come down 6, puts me right here for E. When I look at F, it says to go 6 to the left and 3 up. So 6 to the left and 3 up puts us right here, which is in quadrant 2 for F. And then our last point here, G, says to go to the right 7, but don't go up or down at all. So that also leaves us on the x-axis. So it's worth mentioning that any time that you have an ordered pair that has a 0, it's going to end up somewhere on the axes. It might be the origin, or it might just be one of the two axes. But just watch those zeros because they sometimes mess us up when we go to graph. But there we have it. That is our coordinate plane.